This is the test one review for Math 136. I'm going to go ahead and work through all of the problems. So solve the equation by factoring. Okay. So I have 3x squared plus 11x minus 20 is equal to 0. So I'm going to attempt the AC method. So if this is factorable, this method should work. And I'm choosing this method because I have this 3 up front. So I'm going to take A times C. So I have 3 times negative 20, and I get negative 60. So now I want to find something that multiplies to give me negative 60, and then adds to give me 11. Since my B is 11, that's why I'm choosing that. So multiplies to negative 60, adds to 11. Oops. Now, since they're multiplying and giving me a negative number, that means they have opposite signs. And since the B value is positive, that's telling me that the one with the greater magnitude is going to be the one that's positive. And if you're not even sure where to get started, you can always just start with 60 times 1. So 60 times negative 1 in this case, since they should have opposite signs. And then that gives me 59. And then 30 times negative 2 gives me 28. And then 15 times negative 4 gives me 11. So now that I found something that adds to 11, then that's telling me that I'm going to split up this middle term, this 11x, into 15x and negative 4x. And it actually doesn't matter which order you do it in. So I'm just doing it that way. So if you simplify that, it simplifies back to 11x, but the strategy here with the AC method is to find a way to break up the middle term so that you can use factor by grouping. So my first group is there, and my second group is there. So the greatest common factor for the first group is 3x. And when I factor that out of the first two terms, I'm left with x plus 5. The second two terms, so they have a common factor of 4. Now, if that leading term is negative, you want to bring the negative with it. So I'm going to factor out a negative 4, which leaves me with an x plus 5. Okay, now I have a common factor of x plus 5. So I'm going to factor that out next. Okay, so now I've factored it. Next, I'm going to use the zero product property. So I'm going to set each one of those factors equal to 0 since they're multiplying to give me 0. So I get x is equal to negative 5, and then 3x is equal to 4, and x is equal to 4/3. Okay. So My answers are -5 and 4/3. Okay, solve the equation by the square root method. So I have I have the quantity of 2x minus 3 squared is equal to 121. I'm going to take the square root of each side. Now I have 2x minus 3 is equal to plus or minus 11. Okay, so 2x is equal to 3 plus or minus 11. And then x is equal to 3 plus or minus 11 over 2. Now, if that 11 was a radical, you wouldn't have to worry about simplifying this much further, but there's two distinct answers here. I want to write down 3 plus 11 over 2, and x equals 3 minus 11 over 2. So now 3 plus 11 over 2, so that's 14 over 2, which is 7. And then 3 minus 11 over 2, so that's going to be -8 over 2, which gives me -4. Okay, so my solutions are 7 and -4. You should be plugging these into a calculator to double check to see if you're getting the answer correctly. And the place that you want to plug them into is that original equation. So there are a few problems where the check is mandatory because you could get the answer wrong if you don't include it. So here's what a check looks like. So if I want to check x equals 7, all I'm doing is I'm plugging 7 into the original equation to see if it makes sense. So 2 times 7 is 14, minus 3 is 11. So I have 11 squared is equal to 121. So 121 is equal to 121. So that checks. Okay, and then x equals -4. So 2 times -4 minus 3 squared is equal to 121. Is it? Let's check and see if we get a true statement. 2 times -4 is -8. -8 minus 3 is -11. So I have -11 squared is equal to 121. When I square -11, a positive or a negative times a negative gives me a positive answer. So I have 121 equals 121. So that checks out. So both of the answers I found are correct answers. Okay. Okay, solve the equation by completing the square. And if it says by completing the square on the test, make sure you're doing it by completing the square. I can only give partial credit if you find the correct answer using another means. Okay, so I want to move the 3 over 49 to the other side of the equation. So I add it to both sides, and now I'm here, and I'm leaving a little bit of space. So next, I want to look at my b value. So my b here is -2/7. And the way I'm thinking about this, so if I had a number up front here, I would actually be dividing through by that, and whatever my b value is, it's going to be, once I've gotten this down to where it's x squared where the coefficient's 1. So next, I'm going to take my b divided by 2. And remember, another way to think about dividing by 2, it's equivalent if you multiply by a half. These are the same thing. So I'm going to take and multiply that -2/7 by 1/2. So the 2's cancel out, and I'm left with -1/7. So this is my magic number. Then I'm going to take that magic number and I'm going to square it. So I get 1/49. This number completes the square. So I'm going to add 1/49 to each side of the equation. Now, what's nice about this completing the square method, now that I have completed the square, this is making a perfect square trinomial. So the square that we're completing is a perfect square trinomial. Which means that follows a particular pattern. So this A, well, okay, let me pick some different letters. I'll use capital A and B. So A plus B squared equals A squared plus 2AB plus A squared. So that pattern lets us say, oh, well, our magic number here is this, oh, sometimes I can talk and write, guys. So did I say A squared? Because I meant B squared there. So perfect square trinomial, it's A plus B quantity squared is equal to A squared plus 2AB plus B squared. And you can flip those middle two things around if you want, if that makes you feel better. Nope. Because what we're doing is we're taking this 2B, so that 2B, that's equivalent to this -2/7 from before. And we're dividing it by 2 to get it to B, this capital B I have written down, and then we're squaring it to get that capital B squared. In any case, all right, so I know my magic number is -1/7. That lets me instantly factor the left-hand side to be x minus 1/7 quantity squared. Okay, and then, hey, they have a common denominator already, so on the right-hand side, I get 4/49. Now, at this point, I'm going to solve using the square root method. And remember, anytime that you're using a square root on both sides to solve an equation, if it's an even index, you need to put in that plus or minus. So now I have x minus 1/7 is equal to plus or minus. So that square root, so if I have the square root of 4/49, the square root distributes to the top and to the bottom. So then that means I have plus or minus 2/7. Okay, so now x is equal to 1/7 plus or minus 2/7. So x is equal to 1/7 plus 2/7. and x is equal to 1/7 minus 2/7. So I get x is 3/7 and x is negative 1/7. And those are my two solutions. If I wanted to check them, I could plug it into a calculator, or I could do it on the paper. But this is a check to see if you've done it correctly. Okay, find the real solutions of any of the following equation. Use the quadratic formula. Okay, so my coefficients are a equals 1, b equals 5, and c equals 2. The quadratic formula that you have to have memorized for this test is negative b plus or minus the square root of b squared minus 4ac, and then that's all over 2a. So I have negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 2. Okay, and then that's all over 2 times 1. Okay, and now it's just arithmetic. So I have negative 5 plus or minus the square root of 25 minus 8 all over 2. So negative 5 plus or minus the square root of 17 over 2. And I actually can't make it look any better than that. So my solutions are negative 5 plus radical 17 over 2 and negative 5 minus radical 17 over 2. Okay, write the expression in standard form a plus bi. So that's the standard form for complex numbers, or the standard rectangular form. So 9 plus 6i minus negative 4 plus I. So I have two complex numbers, 9 plus 6i, negative 4 plus I, and I'm subtracting them. Now, check your parentheses up front. So on the left-hand side here, there's nothing up front, so I can just rewrite that as 9 plus 6i. Here, I have a negative sign out front of this complex number because I'm subtracting it. I can actually just distribute the negative sign through. So negative 4, so that's plus 4, and then minus I. And now that we've written it this way, you're just combining like terms. So 9 plus 4 is 13, 6i minus I is 5i. That's all there is to adding or subtracting complex numbers. Manage the parentheses and then combine like terms. Write the real number on the left and write the imaginary part on the right, and you're good to go. Okay. So the most challenging thing to do with complex numbers is divide them. So I have 4 plus 2i over 5 minus 8i. And to divide these two complex numbers, I need an ingenious trick. And that ingenious trick here is multiplying by a very creative 1. So I want to take the complex conjugate of the denominator. and that's going to go here and here. So the complex conjugate of 5 minus 8i is going to be 5 plus 8i. Okay. Now, at this point, you can just FOIL the top and bottom. There is a shortcut that I'm going to use for the bottom. So first, outer, inner, last. So up top, I'm going to take 4 times 5 to get 20. My outer would be 4 times 8i. That gives me plus 32i. And then inner is positive 2i times positive 5. So that gives me 10i. And then 2i times 8i gives me 16i squared. And then on the bottom, there's a shortcut. So if I have a complex number times its complex conjugate, it's going to be a real number, and it's just going to be the sum of the squares of the components. So I'm going to have 5 squared plus 8 squared. Okay. Now, if you multiply that out the long way, you'll also end up at the same answer that I will get for the denominator. So no worries. So that's one trick you can get away with without knowing. So 20 plus 42i. Now remember that I squared is equal to -1. And I guess I can also mention that trick. So if I have a plus bi times a minus bi, then the result is a squared plus b squared, which is actually the factoring formula for the sum of two squares. How about that? Okay, so I squared is -1. That means that 16i squared becomes minus 16. Okay, and then on the bottom, that's 25 plus 64. Up top, still just working on things. So I have a 20 and a -16. So 20 minus 16 is 4. I have a 42i. And then 25 plus 64 is going to be 89. And then I have 4 over 89 plus 42i over 89. Okay, solve the equation in the complex number system. So I have x squared plus 100 equals 0. There's no cross term, so I'm going to subtract 100 from both sides. So I have x squared equals -100. I use the square root method. Okay, so now I have x squared, or the square root of x squared. So that cancels. And then plus or minus, the square root of 100 is 10. And since I have that negative side, it gives me 10i. So my solutions are 10i and -10i. Okay, here I have a cross term, so I'm going to have to use the quadratic formula, or I could be using completing the square. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So I have negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 4 all over 2 times 1. So I have negative 1 plus or minus the square root of 1 minus 16 all over 2. Negative 1 plus or minus the square root of negative 15 over 2. So now the 15, I can't really do anything with that. So that's going to stay inside the square root, but it's a negative 15, which means I can write this as a I times radical 15. And if we look, the radical 15, I can't pull anything out of there. There's no common factors, so I don't really need to do much to finish this off. So I have negative 1 over 2 plus I times radical 15 over 2, and then negative 1 over 2 minus I times radical 15 over 2. Okay. So now this one's asking for real solutions. So let's see. The radical is already by itself. So what I need to do next is just square both sides to eliminate the radical. So on the left-hand side, I get 22x minus 33. And on the right-hand side, I get x squared plus 8x plus 16. Don't forget that when you're multiplying this binomial out, you're going to get that cross term, 8x. So next, I want to collect my like terms. So I'm going to subtract the 22x from both sides, and I'm going to add 33 to both sides. So I have 0 is equal to x squared minus 14x plus 49. And I just happen to recognize that as a perfect square trinomial. So that factors to x minus 7 squared. So I have, I can use the square root method on it at this point. So I get x minus 7 is equal to 0. Or you can use the zero product property, however you want to think about it. So I end up here. This, since there was a radical, you have a required check. Due to the radical. So I'm going to check if the 7 makes sense. So is this equal? So 22 times 7 I have 154 minus 33. Is this equal to 11? So 154 minus 33, I get 121. Now, that radical's just there, so it's just going to be 11. It's not plus or minus 11, it's just 11. So I get 11 is equal to 11, which is true. So then we accept this answer here. Whoop. So my final answer is 7. Okay, next I have the cube root of 2x plus 5 is equal to 2. I'm sorry, not equal to 2, plus 2 is equal to -3. So I want to get the radical by itself. I'm going to subtract 2 from both sides. So I have radical 3. I'm sorry, square root of 3. Oh my goodness, I can't talk. I have the cube root of 2x plus 5 is equal to -5. So now I'm going to cube both sides to cancel out the cube root. So on the left-hand side, the cube cancels out the cube root radical, which gives me 2x plus 5. On the right-hand side, I have -5 cubed, so that's -5 times -5 times -5. You have an odd number of negative signs, so you end up with a negative 125. And we can subtract 5 from both sides. And we have 2x is equal to -130. And then we can divide both sides by 2. And we end up with x is equal to -65. Now, with the odd indexed roots, the check is just a check for correctness. So I have 2 times -65 plus 5 in the cube root, and then plus 2. Is this equal to -3? So I have cube root, so that's -130 plus 5. Okay, plus 2. Is this equal to -3? So now I have the cube root of -125. So then that's going to give me -5. So the -5 plus 2 gives me -3. So we can see that this is good to go. So my final answer for this is -65. Okay, find the real solutions of the equation by factoring. So now this one's cubic. So I have x cubed plus 10x squared plus 24x is equal to 0. I see a common factor of x, so I can just factor that out. So now I have x times x squared plus 10x plus 24 is equal to 0. So the x squared plus 10x plus 24, let's see. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, so if it doesn't just come to you immediately, you can just work down through it. So I have x times x plus 4 times x plus 6 is equal to 0. And then the zero product property tells us that x is equal to 0, or or x plus 4 is equal to 0, or x plus 6 is equal to 0. So then I can solve the second two equations. And now I have all of my solutions. So I have -6, -4, and 0. Okay, find the real solutions of the equation. Use U substitution. So x to the 6th minus 7x cubed minus 8 is equal to 0. So I'm going to let u equal x cubed. I will let u equal x cubed. All right. And I have this changing the original equation to look like u squared minus 7u minus 8 is equal to 0. So the way that I'm looking at this, I choose my u based off of the kind of this cross term. So I see that x cubed squared is x to the 6th. So that's what happens, right? So if I have u squared, so that's x cubed squared, which gives me x to the 6th. Okay, and now I solve this however I like. So the -8 factors to -8 times +1. So then the -8 plus +1 gives me that -7. So I know that's good. And I have, by the zero product property, z minus 8 equals 0. I'm sorry, u minus 8 equals 0. U plus 1 equals 0. So I get u is equal to 8 and u is equal to -1. And then I have to recall this again. So I got to put these together. So I have x to the 3 is equal to 8, and x to the 3 is equal to -1. So I can take the cube root of both sides. So I get x is equal to 2. And x is equal to -1. Now, there's a bit more to it than that, but I will say this. There's actually 4 more solutions, but they're not real. It asked for the real solutions, and we got away with it. So our real solutions are -1 and +2. The other solutions there are 4 other solutions are hiding in the complex numbers. Okay, another u substitution. So I have x minus 4 squared plus 3 times x minus 4 minus 18 equals 0. So we can let u equal x minus 4. This changes the original equation to u squared plus 3u minus 18. So then I have u plus 6 times u minus 3 is equal to 0. And I end up with u is equal to negative 6 and u is equal to 3 by the zero product property. And then I replace my u's with x minus 4. So I have x minus 4 equals negative 6 and x minus 4 is equal to 3. So I have x is equal to negative 2 and x is equal to negative 1. Oh, I take it back. Positive 7. So I have, when I add 4 to both sides, I get a positive 7. So I have negative 2 and positive 7. And since I goofed on that, let's just double check. So if I plug in my negative 2, so that's negative. So if x is negative 2, my original equation is negative 6 squared plus 3 times negative 6 minus 18. So I have 36 minus 18 minus 18. Yeah, that's 0. And then if x is equal to 7, so I have 3 squared plus 3 times 3 minus 18, is that equal to 0? So I have 9 plus 9 minus 18 equals 0. So yeah, that one works too. So I'm happy with these. Okay, my computer's not being responsive. Okay, there it went. So this was my check. And it looks like it went a little bit crazy on me here. Okay, there we go. Write the inequality using interval notation and illustrate the inequality using the real number line. So negative 5 less than or equal to x less than 2. In interval notation, that's negative 5 inclusive. So I use a square bracket, comma 2, parentheses, because it's not inclusive. So I'm going to put that up here. So negative 5 to 2. And then negative 5. Let's see if I can mark that just a little bit better. To positive 2 on my number line. And it just mimics the interval notation. Okay, so if you're asked to draw the inequality on the real number line, that's a graph in one dimension. Don't forget to do that. It's part of the points. So 3x plus 10 is less than 37. Okay, same deal, solve the inequality, express in interval notation. So I'm going to subtract 10 from both sides. I have 3x is less than 27. And I need to divide both sides by 3. It's a positive number, so the direction of the inequality symbol stays the same. So I have x is less than 9. So then in interval notation, I have negative infinity up to 9. and it's not inclusive on anything. Oh, positive 9. And then, so I put parentheses there. And again, this is just mimicking the interval notation. And I put a arrow tip on there to indicate that it's going to negative infinity, just like that. And if you use the open circles and closed circles instead, that's fine. Okay, same deal, solve this and then graph. Okay. So let's subtract 1 from both sides. I'm going to add 5x to both sides. So I have x is greater than or equal to -5. Okay. And if it feels better for you, you can flip this around the other way and write it like that, if that helps you figure out how to write the interval notation down. So my interval notation is -5 to positive infinity. You can always drop in hypothetical values of x and check and see if it's true or not. That can help you get your head around these. So I have -5 to positive infinity, and we're inclusive on the -5, never inclusive on the infinity. Here, I'm not going to label everything. I can just mark a -5 somewhere and then draw my graph. Just like that. Okay. Number 17, we have 8 is less than or equal to 3/2 x plus 5 is less than 14. Okay, so with an inequality like this, I can work on all of the sections simultaneously since the variable's in the middle, and it's not in the denominator or anything like that. So this is fine as long as it's linear like this. So I want to get the 3/2 x by itself first. So I'm going to subtract 5 from each section. So now I have 3 is less than 3/2 x is less than 9. Next, I want to get rid of the 3/2, so I can multiply each section through by 2/3. It's positive, so it's not going to flip the direction on anything. So I end up with 2 is less than or equal to x is less than or equal, oh, I'm sorry. That should just be a less than. So it's less than 6. And then just let me double check here. Okay. All right. So in interval notation, this is 2 to 6, and it's going to be inclusive on the 2, and it's not inclusive on the 6. And I don't see the number line, so I'm going to just put one in because it's still under those instructions. And you don't have to get too fancy with this. So as long as you understand this, I'm not too worried about you, articulating out the whole thing. It's going from 2 to 6. We're inclusive on the 2, not inclusive on the 6. Okay. The absolute value of 2x plus 6, all plus 3 is equal to 5. So I subtract 3 from both sides. So I have the absolute value of 2x plus 6 is equal to 2. This splits into two equations. One version, you just write it down without the absolute value. And then the other version, and this is a shortcut. Uh, the way that you can actually think about this is, so once you have it here, really a good way to think about absolute value is you can replace it with this, and then you have your two equations. This is the way I personally like to think about it, because it's super versatile and it keeps me out of trouble. So this is the other way to think about it. Okay, in any case, either way, we end up here somehow. This one over here is really just one step away. Multiply both sides by -1, and then you end up with the 2x plus 6 is equal to -2. So you can see the two ways are equivalent. Uh, this way of thinking about it, though, actually really simplifies it when you're looking at the inequalities. And to be quite honest, uh, when I think about it this way, I don't have to think as hard, uh, except when you're kind of pasting some things back together, I guess. All right, let's get on with it. So I have these simple equations. So subtract 6 from both sides, and I get 2x equals -4. So x is equal to -2. And subtract 6 from both sides over here, and I have 2x is equal to -8. So x is equal to -4. And let's see. So -2 times 2 times -2 is -4. -4 plus 6 is 2, and the absolute value of 2 is 2, plus 3 is 5. And then 2 times -4 is -8. Plus 6 is -2. Absolute value of -2 is +2. Plus 3 gives me 5. So both of those work. Okay, so 3 times the absolute value of x minus 3 is equal to 18. And one thing I can do is divide both sides by 3. So I have the absolute value of x minus 3 is equal to 6. So then I can rewrite this as x minus 3 equals 6 and x minus 3 equals negative 6. So then I get x is equal to 9 and x is equal to negative 3. Okay, and I'll leave checking this one as an exercise for you. Solve the inequality, express your answer using interval notation. Okay, this is where they can get a bit trickier because of the inequalities. So I still want to get the inequality by itself. So now I have the absolute value of x plus 7 is less than or equal to 9. So if it's a less than or equal to, then I can rewrite this as negative 9 is less than or equal to x plus 7 is less than or equal to 9. And now I can just solve each section simultaneously, or I guess operate on each section simultaneously is what I should say. So negative 16 is less than or equal to x is less than or equal to 2. And then in interval notation, since they're inclusive, I have square brackets, negative 16, comma, 2, closing square bracket. And again, that other way to think about it, so once we had it to this point here, the way that I like to approach these is I'll take the absolute value and I'll rewrite it as plus or minus. And now that gives me two inequalities. I have the x plus 7 is less than or equal to 9, and I have the negative x plus 7 is less than or equal to 9. Okay, and then I solve each one of these separately. So I get x is less than or equal to 2, and then for the other one, so there's a few ways that you can approach this. Just as a way to review multiplying by a negative. So let's multiply through by negative 1. Let's see, I need to give myself a little bit more room here. So less than or equal to negative 1 times 9. Now I made a little mistake there. I got so trapped in my parentheses, I forgot to flip the symbol around in the other direction. So since I multiplied by a negative sign, or by a negative number, the direction changes. So now the negative gets canceled on the left-hand side. So I have positive x plus 7. The direction changed. And then I have negative 9. And then I can subtract 7 from both sides. So I have x is greater than or equal to negative 16. So now I have these two inequalities. And now I have to kind of put things together. Now, when they're separated like this, it might be a little bit easier to keep track of things if you just make a little number line graph for yourself. So less than or equal to 2, so that means it's going this way. And for this one, so negative 16 greater than, that means it's going this way. So in interval notation, if I wrote both of these as separate statements, I'd have negative infinity to 2 And here I'd have negative 16 to positive infinity. But what's going to happen is we need these to both be true at the same time. So we end up combining these two ideas together. So we have this negative 16 to positive infinity. And then I have to do an intersection. So the negative infinity to 2. And where these two things intersect, now hopefully you can appreciate the shortcut that the textbook is giving you. So I have one doing this, and then the other one doing this. And the intersection of these ends up being the final result. So hopefully you appreciate that shortcut. So this is longer way, but more, I guess I would say more informative on kind of the nuts and bolts of it, on how the stuff is working. I'm still not super deep on it, but maybe a bit deeper on how to think about it. And I'm still, still kind of a surface level look at things. But this idea of replacing the absolute value with a plus or minus, the thing that was in the absolute value, this is super useful, especially if you don't work with these all the time and they just kind of come up. If you can at least remember this allows you to piece together how the thing's supposed to work. And I've mentioned that I hate memorizing things. So let's say I quit math and I don't do math for like 20 years. Uh, I'm probably going to get confused on some things, but on the absolute value, this is how I'll remember to do that. And that'll let me get away with forgetting some of the other stuff. Okay. Absolute value of 5x plus 2 is greater than 3. So with this one, since it's a greater than or equal to, in this case, it's just greater than, I'm still going to write that at face value without the absolute value. And then I write the word or, and then I have 5x plus 2, and I flip the direction of the inequality, and then I flip the sign. So 5x plus 2 is less than negative 3. And then I just solve each one of these. So I have 5x is greater than 1. So x is greater than 1/5. Or 5x is less than negative 5. So x is less than negative 1. So now to figure out how these go together, so if x is greater than 1/5, so you can think of that as 1/5 to positive infinity, or if x is less than negative 1, that's going to be negative infinity up to negative 1. Those are all the numbers less than negative 1. So now I want to have this in increasing order, so I'm going to rearrange this. I want to come up from negative infinity to 1, not inclusive, and then I'm going to write the union symbol, and then 1/5 to positive infinity. And these These are all of the numbers that I can plug into this inequality and get a true statement out of it. And again, that alternative way, you don't have to do this. This is completely optional. But if we're here, you can replace the absolute value with this. And then you have 5x plus 2 is greater than 3, or negative 5, I'm sorry. Here, let's find an eraser. So 5x plus 2 is greater than 3, or negative quantity of 5x plus 2 is greater than 3. And then if you do an operation to move that negative to the other side, you get 5x plus 2 is less than negative 3. So really, again, all this is from the textbook, it's a shortcut. Okay, translate the sentence into a mathematical equation. Be sure to identify the meaning of all the symbols. So this is number 22. The total cost of producing refrigerators in one production line is $3,900 plus $500 per unit produced. So let's call X units produced. And then we can say the cost is C. So this is cost. So then my cost, so it's $500 per unit. So it's going to be 500 times X, and it costs $3,900 just to turn on the production line. So we just add that on. So if you get confused on this, all you could do is just say, how much would it cost to make 4 refrigerators? So if it's $500 per unit, I'd be taking the 500 times 4, and then it's plus 3,900 that just to turn it on that day, it costs 3,900. If I make 0 refrigerators, I'm still paying 3,900. Okay. I see some spooky writing on here already. Let me see if I can get rid of it. Oh no. Okay. A bank loaned out $57,000, part of it at a rate of 11% per year and the rest of it at a rate of 7% per year. If the interest received was $5,270, how much was loaned at 11%? So we have the 7% and the 11%, and we have, I guess, the combined or together or whatever you want to call it. And we can make a table. So PRT, and then we're going to figure out the interest, because what we're trying to figure out is the interest on the 11% plus the interest from the 7% is going to equal the $5,270. Now, the principal, we're being asked for how much was loaned at 11%. So that's going to be my variable. I'm going to let that be X. So once I find X, I'm done. And the total amount of money is $57,000. So to figure out the other one, you could call it Y, or just to get done a little bit quicker, we can call it 57,000 minus X, because the principal on the 7% plus the principal on the 11% should add up to the 57,000. Hey, the interest rate is 7%. I'll go ahead and just convert that to a decimal. The interest rate for the next one is 0.11, just converted from 11% to a decimal. And then this is unnecessary. We'll assume the time for each one of these is 1 year. And then we don't need to think about the time on the combined. So the interest is PRT. So I have 57,000 minus X times 0.07 times 1. And then I have X times 0.11 times 1. So I have 0.07 times 57,000 minus X. And then I have 0.11X. Now the total interest is $5,270. So the interest on the 7% plus the interest on the 11% is going to add up to that 5,270. So I should have 0.07 times 57,000 minus X plus 0.11X is equal to 5,270. Okay. So I have 3,990 minus 0.07x plus 0.11x is equal to 5,270. Okay, so next I'm going to subtract the 3,990 from each side and then combine like terms. So I get 0.04 times x is equal to 1,280. And last, I'm going to divide both sides by the 0.04. And I end up with $32,000. So I'll just go ahead and slap the dollar sign on there, make it look nice. Okay. And then make sure to put it in the answer box. The manager of a candy shop sells chocolate-covered peanuts for $7 per pound and chocolate-covered cashews for $12 per pound. The manager wishes to mix 70 pounds of cashews to get a cashew peanut mixture that will sell for $9 per pound. How many pounds of peanuts should be used? Assume that revenue from the mix will be the same as if sold separately. In other words, there's no markup when we do the mix. So we have peanuts and cashews. They're chocolate covered. So, but I'll just keep track of them this way. And then mix. So we have the price per pound. So for peanuts, it's 7. Cashews, it's 12. And the mix is going to be 9. And then the weight in pounds. And it's asking for how many pounds of peanuts. So we'll call that X. Now, you can't always expect these to be the exact same kind of problem. In this case, they didn't tell us how much they wanted the mix to weigh. They told us how many pounds of cashews are being used. Oh, no. Okay. My cursor's going crazy here. So we're using 70 pounds. All right, I'm just waiting to see if it's possessed. Okay, so then our mix is going to have a weight of X plus 70. So we have X pounds of peanuts, 70 pounds of cashews, and then the mix is going to be X plus 70. And then the price, so if I take the price per pound times the weight in pounds, that's 7X dollars in peanuts, 12 times 70 for the cashews, and then 9 times X plus 70 for the mix. And we want that the cost of the peanuts alone plus the cost of the cashews should be the same as the weight of the mix. If I have the same pounds of peanuts and cashews in the mix, I want that to be the same as if they were sold separately. And now we have something a little bit more basic to solve. So I have 7x, let's see, so this is 840 is equal to 9x plus 630. So let's get everything separated here. So subtract the 840 from both sides. Subtract the 9x from both sides. Okay, so I get negative 2x is equal to negative 210. Divide both sides by negative 2. So I have x is 105. And if I want to check that, I can just punch it into a calculator. So I have 105 pounds of peanuts. So then at the end, so 105 pounds of peanuts. So that's 7 times 105. So I have, so this is just one way to do a check at the end here. So I have $735 is what I figured out. And then we have $840. And then 9 times 105 plus 70. So this is $1,575. So I'm just plugging in X and multiplying out. So then the check is the 735 plus the 840 equal to the 1575. So now if I add these together, I get 1575. So that's kind of reassuring. So I'm happy with my answer now. Okay. And then I think I have just the one more here. BJ can overhaul a boat's diesel engine in 20 hours. His apprentice takes 60 hours to do the same job. How long would it take them to work together, assuming no gain or loss in efficiency? So this is a related rates problem. So BJ, his apprentice, and together. So we can think engine. So each one of these individuals or the team, they're going to overhaul an engine. And then they told us the time it takes. So BJ can do it in 20 hours. The apprentice can do it in 60. Together it takes, I don't know, let's call it T. And then the rate for each one of these. So BJ is one engine per 20 hours. The apprentice is one engine per 60 hours. And then together they do one engine in T hours. So now the rates for the people working individually, I'm going to add together. So 1 over 20 plus 1 over 60. And that should be equal to the rate of when they're working together. Okay, and if you want, you can multiply through by 60 to, or I'm sorry, 20 times 60 times t to cancel everything out. I'm going to go ahead and just add the fraction on the left-hand side. So I notice that there's a common denominator of 60. So I'm going to multiply the 20 by 3 over 3. So I have 3 over 60 plus 4 over 60. Oops. Plus 1 over 60. I don't know why I changed it. Is equal to 1 over t. So now 4 over 60 is equal to 1 over t. Since I have that common denominator, I just add the 3 and the 1 to get that 4. Now 4 over 60 reduces to 1 over 15. And however you want to think about this, like you could say we cross multiplied it, all kinds of ways to think about it. We end up with, if we take the reciprocal of each side, et cetera, t is equal to 15. Good luck on the test.